Hi everyone, this video opens a new series about Semantic Kernel SDK, which is a lightweighted open source development kit that lets you easily build AI agents and integrate the latest AI models into your C#, Python, or Java codebase. It serves as an efficient middleware that enables rapid delivery of enterprise-grade solutions. So in this introductory video, I will show a simple code and the necessary setups, how to run a simple semantic kernel agent. So first of all, we will need to enable our large language model. In this example, we will use OpenAI large language model deployed in the Azure environment. And for that purpose, we need to configure the information required by the semantic kernel agent to get access to the OpenAI model in Azure environment. So first of all, you will have to create the project in Azure AI Foundry. I have already created the project. After that, you have to go to Foundry portal, and here you should be able to select a model to deploy them. If you are on the free tier, you won't be able to deploy the models, so you will have to switch to the on-demand pay-as-you-go plan, and after that you will be able to deploy the models. So the models you can deploy are listed here. I have already deployed few models. Two of them are for ChatGPT 4o Mini and GPT-5 Nano, and I have also deployed one embedded model. So in this demo, I am going to use GPT-5 Nano model. So to use the model, we need target URI, which will be our deployment endpoint. We need key, which is our API key, and we need a model name. Also, you can see here already code snippets are provided to use the model out of the box. And you also need to provide the API version. In our case, API version will be different, but this is also required parameter. So now, once we understand how to set up the environment in Azure and how to deploy the model and get all the necessary information from inside the Azure environment, we can go and check the code. Now let us do the code walkthrough. So first of all the calls in this code will be asynchronous calls. So we are going to use async.io. We will need OS module to load the environment variables, and we will use the .env module to load the information from the env file. Specifically about the semantic kernel, we will need a semantic kernel library, and from semantic kernel agents, we import chat completion agent. This will be our main module to implement the agent. Next, within the chat completion agent, we should use the LLM service or simply service. For this purpose, we import semantic kernel, connectors, AI, OpenAI. And here we use Azure chat completion. So this is the interface which helps us to bind LLM to the agent. So we will run the entire code using async.io.run, and our code is in the main function. So first we load our environment variables and we assign endpoint to Azure endpoint. For simplicity, I provide normalized Azure endpoint helper function, so you can have a look in details which update it's doing to the URL depending on the shape of URL. Next is the deployment name. In this case, the deployment name is GPT-5 Nano. And here you can also see the Azure OpenAI endpoint. It is basically your resource name or your project name, service, AI, Azure, azure.com OpenAI V1. And then finally, we need Azure OpenAI API key here. And API version is 2024-10-21. So we do a sanity check. If we cannot find the environment variable with the endpoint, then we raise an exception, missing required environment variables. If everything goes smooth, if no error is generated, then we are able actually to start our chat completion agent. And within the agent, we have to define the service. So basically, this is binding LLM to Semantic Kernel agent. In this case, we use Azure Chat Completion LLM. So we need to provide deployment name, API key, endpoint, and API version. And all these parameters are mandatory. For example, if you omit API version, it will not run. So from this point of view, this Azure Chat Completion and in general Semantic Kernel code is very sensitive to the parameters. So you have to be very accurate which parameters are required, how to provide them. So finally, we provide a name, Semantic Kernel, or SK for short, SK assistant, and we give very general instruction. You are a helpful assistant. So basically, instruction is a system message to prime the LLM with its expected role. Once agent is set up, we can invoke the agent using getResponse method, and here we provide a message. In this case, I would like to ask agent to write a haiku about Semantic Kernel. After the getResponse invocation, we will print the content. So let me run the code. Okay. Semantic Kernel plugs in ideas into tasks while minds hum within code. So this is the haiku we ask the agent to write. And basically this confirms the complete run of the agent and concludes this very short video about how to set up and run Semantic Kernel agents. So stay tuned for the Semantic Kernel SDK. We will explore different types of agents, different types of attaching the LLM services to the agents, and of course, agent orchestration and agent connectivity to other services. For example, we will illustrate in details a code to implement retrieval augmented generation using Azure AI search engine, and many, many more things. So stay tuned for my video. Please like and subscribe, and see you in the following videos. Thank you.